Our work is based on two software products, HIL and QUADS. HIL is a hardware isolation layer. It gives a layer of abstraction between hardware and infrastructure. HIL divides hardware nodes into isolated groups that don't communicate with each other. These groups we call networks. Such isolation is performed via VLAN technology, virtual local area networks. VLAN technology is available on modern network switches. On this picture, the black rectangle is a network switch. In this simple example, all nodes are connected to this switch. But VLAN isolates nodes into three networks: brown, yellow, and white networks. The yellow network represents free nodes. On the other hand, QUADS stands for Quick and Dirty Scheduler. It also performs network isolation. Unlike HIL, QUADS records a schedule of how nodes should be isolated in the future. A user then can semi-automatically change network isolation based on their schedule. Also, QUADS performs provisioning using a commercial provisioning system called Foreman. On this picture, you can see that QUADS sends commands to Foreman and/or uses the operation move hosts. Move hosts specifically moves nodes from one network to another. This picture illustrates how three nodes are distributed between two networks at time 0. At time 1, node 2 is scheduled to be inside network 2, not network 1. To actually move it at time 1, we send a command that moves hosts. These commands are shown in the cloud. We first schedule node 1, then at time 1 we do move hosts that actually makes changes in hardware.
Hi, this is the HIL demo for HIL and Quads, Demo 1. As you can see here, I already have the server running. The host serve command starts the server. Okay, so what we've already done is we've already registered a node on HIL. We've given it a username and password. We've given it a network interface card and a MAC address. So I'm just going to show you that that's been done successfully. Good, there's node 1. Now just to show you a little bit more about it. Here we have its metadata, name, network interface cards, MAC address, networks, and projects. It's not part of any networks or projects yet. I'm going to fix that in a second. I'm just going to make a new project right here. Oh, I already made it. Let me just connect node 1 to it real quick. Awesome. Then I'll just show under the project that the node is listed there. Okay. So under foo/nodes, there is node 1. Demo for quads. I'm just in the quads directory. I'm going to run the local tests that we developed. Here we go. It's running each and every test possible locally. And here we have it. Here's our current data. We have a couple clouds, a couple hosts. Yeah, and that's about it.
So the goal of the project was to extend Red Hat Quads to be able to use HIL. This gave Quads portability and also gives HIL the ability to couple with dynamic scheduling services. So our minimum acceptance criteria would be to enable quads to be able to use one allocation environment and one provisioning system that can be configured at runtime. And these are our stretch goals at the start of the project. That is to implement Juniper Switch driver for HIL so quads can rest on top of HIL completely, and to support multiple allocation environments and multiple provisioning systems. So initially when we encountered quads, it was tightly coupled with Juniper switches. As you can see from the figure on the right, we decoupled Juniper from quads and also implemented the HIL driver. Now if you see the rightmost figure, we planned to achieve our goals in the project by that hierarchy, but we soon realized our misunderstanding with the mentors, and then we went back to the same hierarchy to what was proposed earlier. So what we accomplished. So in Sprint 1, we extended Quad's command line interface to be able to call HIL's RESTful API. In Sprint 2, we created is-a-has-a diagram for Quads and HIL that maps data abstractions to hardware for both applications. And further, we developed the HIL API extension to the Quads command line interface to include networks and establish the Git workflow. In Sprint 3, we actually began the decoupling work and created abstract hardware service class in Quads. And then we inherited from that to mock driver, Juniper driver, and wrote the HIL driver in Quads. In the next sprint, we split the hardware service into an inventory service and network service, which we initially faced a problem with the inventory service. And then we implemented concrete subclasses for mock and Quads native. And we also began to implement the unit testing framework. In the last sprint, we reorganized code base in Git and prepared for upstream merging.
During our initial investigation of the HIL and Quads applications, we realized that the interaction with the hardware was coming through a script that you could pass in as an argument. So we realized that a really quick way to connect HIL and Quads would just be to write another script that interacts with HIL and pass it in as an argument to the Quads move hosts. And so we implemented that just to kind of demonstrate a really quick solution that had a lot that kind of demonstrated a lot of things that we wouldn't necessarily want, and show why we chose to pursue a more abstract way of doing it. Usage documentation. The way the original Quads works is the following. Quads first pulls all information from its provisioning system, Foreman, and records this information internally. You can see this in this highlighted line with hammer. Hammer is a keyword specific to Foreman. Moreover, to move hosts, Quads uses also an external shell script. You can see this in this another highlighted line. This script is also the only piece of code in Quads that actually touches hardware. We did implement the same design with Quads and HIL instead of Foreman. You can see that we need first to add information about nodes and networks into HIL, then add the same information to Quads. Only after that we can use schedule and move hosts. Again, with an external shell script. Now the script is written specifically for HIL. Let's run this shell test. It works as intended. It first moves the node from cloud 1 to cloud 2, then it moves it back, which means this design works. Although this design allows HIL and Quads work together, it's a bad design, because we have two sources of the same information, and also we need to specify a script in shell, an external script. Because this design is a bad design, we decided to rewrite Quads in an object-oriented and reusable fashion. Okay, so the first thing that we did after we all were able to get the applications up and running
was to look and see where we could start finding points of connection and differences between the two applications that eventually would lead to how we could connect them. So we jumped into the code base and we tried to analyze how they were dealing with the various objects that they were working with, and we saw that both use different abstractions for their data and how it interacted with the hardware. So on the left was our kind of first pass over the HIL abstractions, and on the right you can see the quads abstractions. And at this point, our first step was to figure out how they were going to relate to each other and how we were going to map them to each other. And further investigation led us to see that nodes in HIL, which were the physical servers in the data center, mapped to hosts and quads, and that clouds and quads, which were kind of the networks in the logical networks that quads was setting up to isolate its own hardware, mapped to a combination of projects and networks in HIL. There was no conception of a project in clouds, in quads. In HIL, a project is just a very high-level organization of users that if users belong to a project and networks and nodes, it's something that can have multiple networks, and you can use it. It's kind of more for permissions and authentication. And clouds in quads, they really just use clouds for this, and they didn't really have a project. So we made the assumption that moving forward, we were going to map a cloud in quads to a network and a project in HIL. So you would have one project with one network in HIL, and that wasn't the only way that we could have gone about it, but based on our feedback from mentors and just to keep it as simple as possible, that was the assumption that we made moving forward. We also wanted to look at the behaviors of each application and really try and figure out what behaviors they do in common, how they do them, and also what behaviors are unique to each application. And this is just one example of some of the common behaviors that both of the applications do and how they do them. And this was kind of the basis of moving forward how we would start connecting them. So after we got that information from the initial information gathering phase, we moved on. We wanted to kind of map out both of the applications in full, so we made these class diagrams so that in the future when we were actually making changes to the applications, we could have something to refer to where we would see what would get affected by these changes. So right here is the HIL class diagram, and right here is the quads class diagram. And it was really helpful in figuring out what parts we would want to abstract away in order to start connecting the applications. So we noticed from our class diagrams and from just experimenting and running the applications that the scheduling behavior from quads was really the only thing that was needed when it worked with HIL, because HIL kept an inventory of a lot of the same things that quads does. So we thought that we could, as a starting point, we made a design, we created this abstract class of a hardware service, and that encapsulated a lot of the behavior that both quads and HIL do. You can add new projects, you can add new clouds in quads, and you can add new projects in HIL. networks, nodes, anything involving the inventory, and also in actually moving the physical hardware from one network, one logical network to another. And so we thought that if we could abstract away this common behavior, then you could inherit it in specific concrete subclasses, and then you could each driver could implement its own behavior. So we created the HIL driver, which did all of the HIL behavior, and then we also had a mock driver that we could kind of change as we wanted to, just to get something just to test, and then the Juniper driver, which basically took place of all of the traditional quads behavior. So as we were doing this, we realized that this hardware abstraction was kind of, we were kind of trying to solve two problems. And we realized that on the one hand, we were trying to reconcile this inventory problem, which was the fact that you had both applications were storing their own inventory in different ways. And if we were going to put them together, if we didn't address this, we would end up having all this duplicate data, which we did not want. So we decided to refactor our one hardware service abstraction into two different abstractions, an inventory service and a network service. And the inventory service dealt with all of the inventory specific behaviors, and the network service dealt with actually moving the nodes from one logical network to another. And so that way it was kind of a clear just distinction between the desired behaviors. And then we also subclass each abstract class with a mock, a HIL, and a quads native, which we changed the name from Juniper to quads native to properly describe what it actually was doing, in that it was the original quads behavior. And with this, we also started adding unit tests, specifically using the mock driver, so that way we could, it would be easier to continuously integrate this moving forward. By the end of the project, we had the mock driver and the quads native driver running and tested, and the HIL drivers were currently in progress. There's some behavior that still needs to be implemented, but the framework is there, and it has a clear roadmap moving forward. Demonstrate some key functionalities of the project, of the progress that we made. In the project, we thought that we would show the demo 3 video to illustrate how through the quads config file you can easily at runtime select the hardware services that you want, and we would show the demo 4 video that shows how we implemented the unit testing. So here is the demo 3 video, and the key things to notice are that here we're going to go through each of the different drivers, the HIL driver, the mock driver, and in this video we were calling it the Juniper driver. Still, it became the quads native driver. And you'll notice that only when we're using the HIL driver does it interact with the HIL server that will be running in the bottom left corner, and the inventories will be different depending on which driver that we use. So here we'll start the video. First we're going to start the HIL server, and then we'll show you, here's the quads config file in your bottom right corner. Right now there's no hardware service selected, and we're going to show you what happens. We throw an error message. Okay, so now we're going to use the HIL driver, and if you look to the bottom left corner, you'll see the server. As we make calls, it'll be showing that it's getting calls made to it. So we're adding a new cloud, and you'll see in the bottom left that it got a response, and now here's the clouds that we have in HIL. So now we're going to use the Juniper driver, which is the quads native driver. You'll see there's a different inventory than we had for HIL. The HIL server at the bottom left has not made any indication that it's gotten a call because we're now no longer using HIL. We're doing the same exact commands that we did when we were doing HIL, except it's going to the, we're using quads. Now here's the mock driver. Right now we have it just printing out some information. We have it printing out all the keyword arguments that we pass to it, but later we configure it to be set up for the. So our demo 4 video illustrated how we set up our unit testing framework, and it's basically going to go through quickly. On the right side you'll just see some of the basic quads commands, and then just to show what's in the inventory, and then on the left side it'll go through a little bit of a PyTest module and then show how we test it. So here it's starting. And we're just going to list the clouds. There are 2 clouds. Then listing the hosts. Now on the left, it's going to go to the testing directory where we put our PyTests. And we'll go through, show you a little bit of the testing code itself. We use PyTest fixtures, and basically we just set it up to, we pass in all new data that we create here using the quads CLI. The last 2 tests we hadn't implemented at that point because we were still working on some of the driver functionality. As you can see, it's running. One of them is going to fail because we're using different data, but that can be corrected in the tests. And there is our
learned throughout the course of this project. So first of all, we had to overcome some challenges throughout the course of the project. One being synchronization between the team. It's really hard to get 5 people with very different schedules to be able to work together all the time on a consistent basis. And we also had a lot of issues early on, at least, with communication between the team and our mentors, and that mainly just came from miscommunications as to what they were looking for. But I think that we were able to overcome that with constant communication with them over Slack, and we also had a weekly face-to-face with them, which was very helpful. And then not everyone had experience with Agile before starting this project, and it can be kind of challenging to keep up with 2-week sprints when you're not used to it. But we just made sure to have at least bi-weekly Scrum meetings planned and a sprint planning meeting done as soon as possible after every demo. And just, I think the hardest part of this was understanding the code base of both HIL and Quads. We had to learn 2 different code bases that weren't written by the same people and have varying degrees of documentation, and we needed to learn them well enough not only to understand what's going on in them, but how to break them apart so that we can combine them together. And I think this last piece of this last challenge, the non-availability of hardware to test the code, was one that we weren't able to overcome, but would be looking to do something like that in the future. And so that brings us to our takeaways from the project, and these are just kind of the things that we learned throughout the course. And again, Agile project development was a big part of this project, and we got really comfortable with Git workflows and with Trello workflows, and I think that our mentors worked really close with us to get good Git workflows and to really help us out with creating good Trello cards. And I know that I personally and none of my team as well had done Python unit testing before, and towards the end it became kind of important in terms of trying to get our code accepted upstream, so we all kind of got our hands dirty with Python unit testing, and we learned enough data center networking as it pertains to HIL and Quads. And finally, just some general software engineering techniques, namely the use of abstract classes and how to derive concrete classes for our drivers that Isaac had mentioned earlier. And so that brings us to limitations in future work. So as Isaac mentioned, we weren't able to fully implement our desired behavior with HIL. We have the framework, but it's just not completed yet. And while we do have some unit testing available, we weren't able to do end-to-end unit testing. And so for future work, we'd be looking to make our mock driver more robust so that we can get end-to-end unit testing without any hardware. And we want to be able to implement the remaining functionalities of HIL. And we want to be able to improve our abstract design to be more object-oriented. We have discussed this with our mentors, and there's some places that we could clean up our code to make it a little bit more Pythonic. And finally, we would like to be able to write a Juniper switch for HIL so that quads could potentially just rest on top of HIL.